We are a company known for making vacuum cleaners, but actually it's much more than that. Actually, we're now a technology company, so we develop plenty of product. So we have different type of vacuum cleaners. We have handheld vacuum cleaners. We also develop a lot of fans, so normal fan, heaters, purifiers. We also have hand dryers, and we have plenty of other products coming. The DNA of Dyson is like James Dyson brought it, is about first experimentation. So we have amazing capabilities. We can make a product in less than a week. And we have different capabilities that allow us to make any kind of test that you can imagine. However, we cannot really access all the information only with testing. For example, when you have a product, you cannot know what happened inside of it, or you cannot have all the detail of the flow. The system model as well is really important, because now we start to have different subsystems which are extremely complex, which are interacting, and we have some contradicting requirements. And we need to be able to look at that in a multi-physics and multi-system environment, and that's where simulation plays a key role as well.
I spend most of my time helping design engineers to understand how their products are performing aerodynamically. So I predominantly use Fluent alongside both Ansys Mesh and Fluent Mesh to model predominantly cleaner heads and the ducting out of cleaner heads. It's quite a complex system, and it requires us to set gaps in geometry quite closely, and Ansys is giving us more and more control in terms of the meshing process to model these small gaps, which are crucial to actually getting an accurate representation of the flow in CFD.
Modern products are becoming more and more compact. Okay, so they're becoming smart, so that means you have a lot of electronic, which means a lot of thermal challenges. You also have, if we do, for example, humidifier, so you have to make water cohabitate with some electronic which are not far away. So you have a lot of massive challenge, and to be able to optimize this at the best, you actually need to look at some multi-physics sometimes. We choose Ansys because it's a street with a lot of capability. We're not only using fluid dynamics, we also use structure capability, also electromagnetic. So we have all those kind of multi-physics environments that we can use in a very clever way. And you have all those development in terms of adjoint modeling and optimization, which are key to what we want to do in the future. So that's why Ansys is our tool. And we have a kind of historical bond with Ansys. I've always been with Ansys and all that, and yeah, we continue this happy relationship.